Hello again and welcome to our p-value. So the first thing we want to point out is that a p-value is the probability of getting results as extreme as observed ones. And now this is always assuming the null hypothesis is true. Now the first question we're going to do is we're going to go straight into it and we do it all on this calculator. So let me show you. So a population has a known standard deviation of this. 3.97 on a sample of 36 items. The selected and sample mean of 23.75. Now we wish to test whether the population mean is less than 25 using the hypothesis, null hypothesis that it equals 25 or is less than 25. So we're going to calculate first the test statistic. Now to do this, we go over to a calculator and we go into inferential statistics, which is here. Press OK. Now there's tests we have to do. Now we're going to do a test, so we're going to press OK here. Now this is a mean. This is a one mean said test we are doing. And you can see it says here that it says the word average, and you see that coming up every so often, and that's how you know it's, or it says sample mean. Or here population mean. So we're doing a mean test with this. So press OK, and as I said, we go to said test. Now we're going to put in the null hypothesis, which in our case is 25. We're assuming this is true. So I'm going to go here, and I'm going to actually change this to 25. Okay, now we can select down here, with this you can actually select this to be in not equal to 25 or greater than 25. Now we need to look at the question, and it wishes to test if the population is less than 25. Less than 25. So in our case we're going to pick less than 25. Press OK, scroll down, next. Now we're going to input the stats. Now before I do it, it's very important to write it all out. So the first thing I want to do is write down the population standard deviation, which in my case here equals 3.97. That's this. Then we're going to write down the number of items we have. That's n. That equals 36. Then we're going to write down the sample mean. We're going to use x bar for that. And the sample mean, which is this number, that equals 23.75. We're then going to write the hypotenuse mean, the mean from the hypotenuse. So hypothesis test, which is 25, and then we're going to write the significance level. Now we'll use alpha. That's usually what we use for significance level, and when we're not told significance level here, we always assume it's 5%. So this is 0.05. Now we can go back to the calculator and input the data in. Now we can see this is a left-tailed said test, left-tailed because it's less than. So we're going to go in here and we're going to stick this in. So x bar, that's right. Sigma, yes, that's right. The number is 36, yes. The significance level 5%, and we press next. Now when you see here we've got a said test statistic and we've got a p-value. Now the p-value is really what we're looking for here. So we're going to look at the p-value, and in our case the p-value is 0.294. So we look at that and we're going to compare that to significance level. Now since 0.0294, which is the p-value, that's the p-value. Sorry, I missed the 0 in here. Just going to rub this off and put a 0 in, 0.0. Should be 0.0 here. Since this here is less than our significance level of 0.05, we reject HO. So what we could write then, if we want to write something, we would write there is significant evidence the population mean is less than 25. So that's how we write it. Oh, look at this. I just noticed that this here should have been written in here. So I should probably actually just grab this and put it down here, and grab this here and put it down here. So based on the 5% significance level, and we can see that, I've just assumed that correctly, and it's done. So that's that done. Thank you very much for watching.